the talk today is really about how can we manage Conda environments in an enterprise environment or a large team of people, and sort of have like this reproducibility aspect to all of this. So I'll be talking a lot more about that. So yeah, a little bit about myself. I'm a software developer at Quansight. I really care about numerical computing and reproducibility in general. Reproducibility became really important to me when I was heavily contributing to a project Nix packages and Nix OS. And that's also really motivated a lot of the Conda-store work that I've been doing at Quansight. And then on top of that, I'm just a contributor to a lot of PyData projects, mainly Jupyter Hub and Dask. And then one thing that's really helped me kind of learn about all these architectural components and stuff is just playing around with the home lab at my house, and just really passionate about just managing some IT stuff at home, and just kind of learning and making all the mistakes at home by yourself. So I just wanted to really quickly talk about Quansight because it's really relevant to the development of Conda-store. So the way I think about it is Quansight is trying to make open source sustainable. And how do we sustain a bunch of these PyData projects such as NumPy, SymPy, SciPy, and the list goes on. And we're coming up with methods on having dedicated developers towards the long-term maintenance of these projects. And if you're interested, just definitely check out the website, and we are hiring for all sorts of positions. So before I talk about Conda-store, I really just wanted to take a step back and talk about why should we even have development environments in the first place. I think when I first started developing, I had one monolithic environment where I just threw everything into it. And there were a lot of issues that I encountered with that. On top of that, you're going to pay the price at some point as a project becomes more popular. Eventually, you're going to have to onboard new developers, contributors, and tell them how to do the testing, how to run your package. And if you don't establish an environment early on, you'll pay for it later. Additionally, I mentioned a little bit about the monolithic environment problem. And this happens because in the Python ecosystem, packages update quite frequently, and things can break on updates quite easily. And then I think really the thing that's the key for me is the reproducibility aspect of it is much more difficult when you have a ton of packages in one environment, and the package size becomes quite large. So now that I've kind of talked about, what is an environment, I kind of want to be general and say there are a lot of ways to manage environments. Maybe you're doing Docker containers, or you have an NPM development environment, or you're using PyPy and virtual environments. And this question of like why Conda would come up. And to me, it's really, if you look at all of these features that I have listed here, I think that Conda is a real outlier. It has great support for Windows, Linux, and Mac OS, especially for compiled libraries. And then having a concept of isolated environments. I'd like to point out maybe if you're using like apt or yum in the Ubuntu, Debian, or RHEL area, those are really dedicated environments that are system-wide. The other thing is programming language agnostic packaging. I think of like PyPy is really great in Python, but it's really Python specific. Same as with R, you'll have like the CRAN package manager. And we're really looking for a general package manager that can solve C++ issues to R issues to Python issues. Additionally, really because of the target audience, we need strong adoption of the package manager in the scientific community. And then the final bit that is really important to me is that the compiled libraries are not vendored. So if you deal with wheels on PyPy, you'll notice that like NumPy will ship with OpenBLOS already inside of it, but it's pinned to a specific OpenBLOS version. And if you say grab another library that needs OpenBLOS and a wheel through PyPy, they'll actually have to vendor in OpenBLOS themselves unless you compile it so you just really run into these issues that Conda has actually solved quite nicely with being able to link to a central OpenBLOS version or a fast Fourier transform library. So I hope this has kind of addressed, why Conda. But then you'll be like, great, I have Conda, I'm using it for managing environments. I have this environment.yaml file, and anytime I need another developer to work on it, I'll just hand them the environment.yaml file, something like that. Well, we were developing, at Quansight, we're developing something called QHub, which is a sort of like auto-scaling open source data science environment. And that works on all the clouds. And one of the big things that we ran into was you really can't just have environment.yaml files for managing environments and have multiple users able to easily change them. So a great example, as we've also worked for clients, is that users want packages now. So a user might say, I need NumPy installed, install it for me now. And then on the other side, there's IT that's responsible for adding NumPy to that environment. And because of reasons such as IT might have licensing constraints, or they might have some rules on what specific versions that can be installed, or vulnerability scanning. After they've gone through the whole approval process, then they have to build a Docker image and then maybe start the service up running with the new Docker image. And really, both sides are quite frustrated in this equation. And Conda-store, our goal is to make it so that we can sort of be the middleman between these two and make it really easy to install packages, environments, and also vet them as well and have certain policies. Another thing that's really important is that if users are able to just create these environment.yaml files, sometimes they'll get lazy and maybe they'll add a new package without actually adding it to the environment.yaml. Maybe they won't pin the specific version that they used, and you really lose a lot of the reproducibility aspect of that. So we needed something that allowed users to create new environments, but at the same time get that reproducibility bit and have a unique key for environment environment that was created. So I hope I'm like giving a really, a broad overview on the frustrations that we had with really Conda env install is not enough. We need management around that, especially in large groups. So what is Conda-store? I'm about to give a demo, but it is something for doing management of environments. It also does builds, and then it serves the environments. So how does it manage them? It provides a web UI that I'll show. I won't be showing, but there is a full REST API behind all of the environment operations. So you could automate this in CI or, whatever service you're thinking of. And it also watches the file system on specific paths that you specify to auto update environments. And then finally, we're working on a JupyterLab extension that will allow you to modify your Conda environments inside of JupyterLab, but also get all this reproducibility and build parts that I'm talking about. It also, importantly for enterprise environments, builds Conda environments in a scalable manner. So it can theoretically build in environments at the same time, just depending on the number of workers that you have. And then finally, it serves these environments via a file system, lock files, tarballs, and a Docker registry, which I'll show in a little bit. And all of this stuff is encapsulated in a full role-based access system, which allows you to have default permissions for unauthenticated users, have different namespaces that certain people can work in, and I'll show that in a second a little bit more. And then I'll also be showing the JupyterLab UI. Before I show that, I just wanted to say really quick, all of this is, you can easily try this out yourself. You just have to clone the Conda-store repository, go into the Docker example, and then Docker compose up, and these services will be up and running. So let me just show this really quick. So here is just the base Conda-store UI that you'll launch into. One thing you can see is here I have some environments that are already pre-populated. Some things you'll see here, Quansight data science environment. And inside of this data science environment, we have built a, I'd say a pinned environment.yaml file that has all of the package dependencies written down. We also have a lock file. If anybody here has seen Conda lock, it allows you to install a Conda environment without having to do the solve stage. which can really alleviate a lot of the memory issues that you have. It's also a very compact representation of your environment. You also see it has like a SHA, actually this is an MD5 hash of the package. So you basically have a really strong guarantee that your environment is the same. So that's the first, and then the second build artifact. Additionally, we have a Conda-Pack. So if anybody here has seen this before, Conda-Pack is a way to tarball up a Conda environment and ship it over, just regularly send it and then extract it on the other side. There's a little command you have to run to rewrite some of the paths, but this provides just yet another mechanism for sharing the Conda environment. And then finally, we have Docker. I'll just demonstrate this really quick. So if I just open up a terminal, I can just demonstrate that this actually implements a full Docker registry, which works really nicely with Kubernetes as well. So if I do local, right now I'm just running this on localhost 5000, Quansight data science. And that one I'm not showing that it didn't pull because I pulled that one before. So let's do one that hasn't been pulled before. We have default PyData, which I definitely haven't done. So it was unable to find it. And then what it's about to do, actually this one didn't have the Docker image built. Let's do prod web dev. So here we can see it started downloading all of the Docker layers. And then as soon as this is done, we'll be in a Docker image. But the nice thing here is you'll see really soon that if we specify an environment, so here is our environment.yaml, we have the packages, the regular spec that we're used to, but it automatically builds all these different build assets so that we can easily, let's say somebody's on their laptop and they want to recreate the environment, they can just Conda install the lockfile. But if they're in a Kubernetes environment, they might want the Docker file. There's another key aspect to this, and that is, I'll just show one that I know gives an interesting use case here. So we have the ability to have multiple builds for a given environment and changes over time. And what this would allow you to do is that if you have multiple completed builds, you can actually do a rollback if one of the environments that you created didn't work out. So that's one of the features that Conda-store really enables is easily switching between builds. The other thing is that every single build has a unique build key associated with it. So if we just go here to this build and look down here, you can see that there's a unique key assigned to every build. And this allows this reproducibility aspect. So if you do need to run an environment, say 10 years from now, you have this really nice way of always addressing the same build and then running that Docker image down the road, along with the tarball and the Conda lock as well. However, I will point out that the Conda lock probably won't work down the road because of how Conda channels work and that the packages may no longer exist at that point in time. Additionally, you can see the full logs of the Conda, the build that actually took place. So really quick, how would a user create a new environment? So you just click create an environment. You can drag and drop new environments in here. The other thing too, we can do this and then Flask. And then we see that it was added. And as soon as it was added, we already see that a build was queued, and very soon we'll see that it's actually building. So you can see how it will automatically start to build these environments. Other things that I wanted to point out was that it also builds these environments on the file system. So I mentioned a little bit about having a Jupyter Lab extension for installing Conda environments. But the big benefit here is that you can see that it's automatically added via Conda MB kernels. And we can, for instance, play with, this is the data science environment that was just created. So if we look at data science, we will see we have NumPy installed. So we can import NumPy, but if we import numba, that doesn't exist. And we can then quickly trigger a new build by just editing this and adding numba. The other thing that you'll notice with this though too, is that we keep track of all of our previous builds. So we have a nice way of keeping track of our environments over time as well. I mentioned a little bit about how there is role-based access behind all of this. So right now I'm currently authenticated, and the way I have this user authenticated is he can see all environments. But let's suppose that I log out. You'll see that as soon as I log out, not all of the environments are available to me. And that's because by default, the default namespace is read-only. And then there are abilities that as soon as you log in, this is going integrations with Jupyter Hub for authentication. And as soon as you're logged in, you now get to see all of the namespaces. So there's really rich controls on environments, how they're created and deleted. So I know that was a really fast walkthrough of a lot of the things in Conda-store, but I just wanted to make sure I hit on all those features there. And I may be cutting this a little bit short with the full presentation if there are time limits. So I wanted to talk really quickly about how does Conda-store actually do the builds. So we have a sort of environment that's kind of just a pointer to whatever the current build is for that given environment. And then we have a bunch of successive builds that are tied to environment.yaml files. And you'll notice that you can have multiple builds for the same specification. And this is because if you have an environment.yaml that's not pinned down, it could happen that NumPy comes up with a newer version. And if you do another build, you'll actually get a newer version of NumPy in the next build. So it's important to keep track of all the different versions through time. So here I just wanted to hit on some of the pain points that Conda-store is really aiming to solve here. So the first one that I mentioned a little bit before was IT and user friction. This is something we saw over and over when working with clients. And that is that all of our end users, maybe data scientists or just regular developers, they need a given package. And it's really hard to understand why IT can't have that package available now. And then on the other side, when you get to see the IT's perspective, you realize like the complexity behind updating environments. And there's a lot of method to the madness on why it takes such a long time. And really both sides are really frustrated with the process. So the things that I really think that Conda-store can bring here is that it has the rich RBAC controls that will allow IT to have like dedicated read-only environments that users can't touch. But at the same time, allowing users to have their own playground environments, but still have restrictions on you can only have these sorts of packages, you can only install from this dedicated Artifactory channel. All of these constraints that IT might want to limit on their users. Yeah, and then I mentioned here the ability to enforce constraints. Another key issue that I just wanted to make sure that I touched on here was the ability to productionize environments. So very often we'd see some users just developing on Jupyter Lab. They come up with this awesome notebook that solves some problem, but the issue is that they need this to be run every week for the next 5 years. And it needs to be run on a regular basis. Well, as soon as they have that notebook in that environment, they really kind of just hand it off to IT and say, it's your job to make sure that this runs forever, essentially. And that's a really tough problem. And I think one of the key issues there is that we don't have a way to reproducibly identify the environment that the notebook was developed in and somehow mirror that when we're running that on a workflow on a regular basis. So how Conda-store helps this is that every build is uniquely accessible. It's available as a Conda-Pack, Docker, image, lockfile, pinned YAML. I have ideas where I'd really like to start producing ISOs, and also for the HPC community, it's really escaping me right now, but their packaging format, I'd really like to produce singularity containers as well. There's really no reason we couldn't do that. Like I mentioned, all the builds output many different forms. Additionally, all environments are all artifacts are put in S3. And this is a really important thing to have affordable storage and also just a really easy way to back up all of the environments and builds that were created. And then finally, anybody that's ever done a Conda update, maybe many times has found a time when you do a Conda update and it gets an inconsistent solve and you run into issues there. So Conda-store actually does a complete new install every single time. And it creates so kind of sacrifices a little bit of space for that really reproducible aspect there. And then this is a feature that I really care about that I wanted to at least show. I got really motivated in Nix. There is a project called Nixery, and it is kind of what I would call an on-the-fly Docker container builder. And I was determined to build this for Conda. So I already showed here how I pulled an existing image, but let's do a Docker run -it. So we'll contact our same Docker registry, but I have a special Conda-store dynamic, and anything after this, it will build a Docker image with those packages installed. So maybe I want Python less than 3.9. I want NumPy, and then I want Flask installed. So you'll notice really quickly I ran this, and it doesn't yet have the Docker image because it doesn't really exist. And if we check really quickly on here and we refresh, we'll see that there's automatically an environment being built. And it's configurable so you can make this hidden so users don't see it. But my main point here is that this allows in a Kubernetes environment, we can kind of stop creating these everybody's had to write Docker files before that seem overly repetitive. And this would allow on-the-fly Docker environments with arbitrary Conda packages installed. You can also configure the base image that's used. But I think for really light things that don't really have any secret sauce in them, I'll give an example. We're trying to run a Jupyter Hub server in Kubernetes. Well, Jupyter Hub is just a Python package that you can install with Conda, and then you just mount in the configuration. But there's really nothing secret to that container. And I don't believe that we should be having to build these custom images with just single or multiple packages installed in them. So this is something that is one of the reasons why I implemented a Docker registry inside of Conda-store, is so that we can do these sorts of tricks where Docker images don't exist. So you can actually see the build just completed, it built a Docker image, and then it started pulling it in. Again, I don't think this is really something that's used heavily, but I think this has a really interesting use case in the future. So here we see I did Python less than 3.9. And if we type Python, we see that we get 3.8 there. Okay. And then finally, just wanted to talk about the roadmap. So one of things after talking to the Conda Forge folks is that it would be really nice to have a remote Conda environment solver API. And most of the issues when you do a Conda install revolve around the solve step and memory issues typically on laptops, and it could be really nice if we had a service publicly that would be able to do these solves. That said, Conda-store is fully open source and you can run it on your own, but we thought it would be nice to offer a service like a remote Conda solver API at some point. I also mentioned this Jupyter Lab UI, which has been important to us because I don't think that the Conda-store UI should be the way that people interact with it. I think it should just be the normal Jupyter Lab flow. And with that, we're trying to use something that Quansight folks have developed called Gator and extend that. Additionally, I'd like to integrate with Jupyter Enterprise Gateway. Anyone familiar with that project, it allows you to kind of separate the kernel from the Jupyter Lab server. And I think that Conda-store and building Docker images could be really interesting in this use case. Additionally, I mentioned a little bit before that I'd like to build also additional environment formats, Singularity and VM ISOs. This isn't immediately on the road, isn't going to immediately be done, but I would like to get this done soon. And that I think it has a lot of value to the HPC community. And then finally, we're working on an integration with our auto-scaling open source data science environment, QHub, to kind of be one of the first trials of fully integrating Conda-store. So with that, I know I spoke really quickly. Probably should have put less on the slides, but I really appreciate your all's time. And if there are any questions, please ask.
Thank you, Chris, for the talk. And I see there are some of the questions in the chat. So the question is, what if I need a package that requires manual compilation, like TensorFlow on ARM machine requires manual compile? What should we do then?
Yeah, so for manual compilation, so right now it's just doing Conda installs from packages that are available on different channels. Maybe I'd recommend there with the build process that once you do your custom build for that given architecture, that you upload it to a kind of a private Conda channel, and then Conda-store could then use that given custom build that you made. I hope that helps answer that, but Conda-store is trying to be more around environment management, and on the individual package level side, we're trying to defer to Anaconda teams, and there's another one that the Quansight folks have been working on, and kind of want to defer to them to really handle the packaging issues.
All right. The next question is, why is the Conda-store Jupyter Lab extension archived?
I imagine that, so you should just look in, okay, why is it archived, right? So originally we were looking at building our own Jupyter Lab extension, and then we found the work that Quansight has been doing on something called Gator, which if you haven't tried it out, I already encourage you to. It works locally with Conda or Mamba for the environments. And we, instead of building another environment management tool in Jupyter Lab, we really want to work with them and kind of to help build the tool that people use to manage environments in Jupyter Lab on.
We have another question, which is what is used as the base image for the Docker builds?
So right now, the base image is an Alpine glibc image, and that's configurable in Conda-store. It uses traitlets underneath the covers. So you can really specify any Docker image that you're able to pull. So if you have a private one, you'll need to put in your Docker credentials, maybe do a Docker login beforehand, but it should be able to pull it just fine.
The last question is, does this play nicely with Mamba too?
Yeah, we actually use Mamba underneath the covers. So Quansight's actually doing some work right now to integrate all of the Mamba solve pieces into Conda to give it just as fast environment solves. But at the moment, the Mamba solves solve much faster. I'd claim maybe 5 times faster or so that I'm seeing, and the memory usage is also significantly lower. So, yeah, we're using Mamba. Long answer for that.
All right, thank you. I think this brings us to the end of the time, and thank you, Chris. Thank you, Chris, for going through this presentation. And this seems like a good thing to use, and I think I'm gonna check it out. Like, I've been using notebooks for quite a while.
Awesome. Well, thank you.
Yeah.